Hi, Nine. So today we are looking at using our trigonometry knowledge to find the unknown side in a triangle. So we're looking at finding the length. So remember our SOHCAHTOA looks like this. And the way that we do this is we rearrange the equation to make the unknown side the subject of the formula. So, for example, find the value of the pronumeral to one decimal place. So remember, the pronumeral is just the letter, so the unknown side. So here's our triangle. Step 1 is to find the trig ratio you are using. So have a look at our triangle. We've got our angle, and this side here would then be our adjacent side, and the other side would be the hypotenuse, which means if we've got adjacent and hypotenuse, we're going to want cos. So remember, cos theta is adjacent over hypotenuse. Then we're going to sub in our information that we've got. So instead of theta, we've got 58. So we've got cos of 58 degrees is equal to our adjacent, which is d, over our hypotenuse, which is 15.2. Now, once we've got this is basically our formula now we're going to work with, and where we need to find the side length d. So what we're going to do is we're going to solve this like a normal equation for the length d. So in saying that, we've got cos of 58 degrees is equal to d over 15.2. Now, to get d by itself, this is in a fraction and it's dividing by 15.2. So we're going to want to multiply both sides by 15.2. And remember, by doing that, that actually eliminates those two and we're left with d. So we've got on this right-hand side, we've got 15.2 times cos of 58 degrees is equal to d, and we can just rearrange it and write it on the other side if you want, so it's easier. And then all you're going to do is literally put that straight into your calculator. So type 15.2 times cos of 58 and press equals, and you're going to get 8.054, which rounds to 8.1 meters. Okay, example number 2. This time this is our triangle. So again, step 1, we're going to find our trig ratio. So using our sides, we've got our, this is our opposite side, and this side is our adjacent side. So opposite and adjacent means we're going to be using tan. So tan theta is opposite over adjacent. Now, instead of theta, we've got 23 degrees and 18 minutes. So tan of 23 degrees and 18 minutes is equal to our opposite side, which is q, over 47. Again, we're going to use what we've got, and we're going to solve for q now. So the same thing, if this is our equation, we can solve for q by multiplying both sides by 47, because that will eliminate that our fraction. So then we've got 47 times tan of 23 degrees and 18 minutes. So that's what you put in your calculator. Remember, you'll have to use your bubble button for this. And that is equal to q. And solving that, we get q is equal to 20.241, which is approximately 20.2 centimeters. Okay, last one. Triangle JKL is a right-angled triangle at the angle K. JK is equal to 35 meters and angle J is equal to 63. Find the length of LK correct to the nearest meter. So the first thing we're going to want to do is obviously draw a triangle that represents this information. We're told it's right-angled, so let's just draw up our right-angled triangle. Okay, And we know that at angle K, that's where the right angle is. So we're going to call that K, which means we've got J and L. All right, so we know that the side JK is 35 meters. So we'll label that 35. And angle J is 63. So we're also going to put that angle in there. Do it in a different color so you can see it. So 35 and 63. Find the length of LK. So we want to find this length here. So we'll just call it X for now. So using our trig, we're going to look at, this time we've got the opposite again, actually. So we've got the opposite and the adjacent. So again, we're going to use tan. So remember, tan of theta is equal to the opposite over the adjacent. This time we've got theta to be 63 degrees, which is X over 35. Then to solve for to solve for X, we're going to multiply both sides by 35. And the reason we do that, remember, is so they cancel each other out. And we're left with 35 times tan of 63 degrees is equal to X. You can write them in reverse to make it easier for you. And again, you literally put that straight into your calculator. So 35 times tan of 63, close the bracket, and you get 68.6913.7 if we go to the nearest, to the nearest meter. Okay, so then it's 69 meters. And that is it. Good luck with all of that.